Welcome back to Math 432, Applied Combinatorics, where we're talking about choice. Sometimes a problem involving choice can be a little bit difficult to understand, or a little difficult to compute. Here's an example. A medical student must work 5 days in February, but may not work on consecutive days. How many possible schedules can she have? This problem is made a little more difficult by one constraint. That is, the may not work on consecutive days. That constraint makes the problem a little more challenging to compute. So let's make this concrete, because that always seems to make things a little better. So let's pull up February. And let's think about, what if the red constraint wasn't there? How would we solve this problem? How would we figure it out? Well, what we could do is we could just give her 5 tokens representing the 5 days she needs to work, and then we just choose 5 days however we want. There. I've chosen 5 days. That's one possible schedule that she could have if the red constraint were not there. So without the constraint, what is she doing? She's choosing days. Her earliest day she can pick is the 1st of February. That's day 1. And then she'll have another day, and another day, and another day, and another day. And that's it up to the last day of February. Okay? So what we do is we just choose the 5 days that she works, and then we take care of this order. It's not really a linear order that's happening here, right? We just say, okay, after we've chosen, we let the first thing be day 1. We let the second thing be day 2, and then we keep going through the calendar for day 3, day 4, and day 5. So it's not a linear order that we have. There's no 5 factorial involved here. The answer, if we didn't have the red constraint, so without the constraint, the answer is 28, choose 5. But what about the constraint? How do we take that into account? How are we going to possibly make sure we don't do something like I've done here, which is put these guys consecutively? This is a problem. You can't just say, oh, well, we'll just sort of adjust it like this, because that's another possibility that we've counted in here. So we need to think strategically about how to handle this consecutive days condition. So one way that we can do that is we can just think about, what condition does it put on these D's? Well, we know D1 can be anything we want in this realm here. And what about D2? It's not the case that D2 just has to be the next day we've chosen. There's another constraint. It can't be the next day. So I cannot choose here and put the 2 like this. I've got to choose something that's farther away. But that's okay. I can still put the 2 here and choose this cell if I want, and think about just putting the 2 after it. So here, I'm thinking about, this is what my purple token is going to count. Not D2, not the second day, but D2 minus 1. That way I can just choose these 2 tokens however I want. And then what about the third day? Well, we know that D2 has to be less than D3 minus 1. The same logic, right? Once I pick day 2, I can't put day 3 here. But we want to compare it to where my purple token is. So purple token's at day 2 minus 1. So let's subtract 1 from this, and what do we get? We get D2 minus 1 is less than D3 minus 2. Okay, so now what can I do? I'm going to think of my next purple token. My next purple token is D3 minus 2. And let's see what happens there when I take those 3 tokens, and I'm just going to choose 3 days. So 1, 2, 3, and now I can choose them however I want. The first token is day 1. The second token is day 2 minus 1, so I'll put the 2 here. The third token is day 3 minus 2, so I go 1, 2 from the third token. And sure enough, I'm spaced out plenty. Even if I put my tokens right next to each other, my days are going to get spread out. And let's keep going with that. So we're going to have D3 minus 2 is going to be less than D4 minus 3, which is less than D5 minus 4. Again, all I'm doing is I'm increasing how much I have to separate them out by. Now, when I pick things, what I'm picking with my tokens, I think about my purple tokens. Sorry, I don't have a purple marker, but I think about my purple tokens as these amounts. These shifted values. And now I can just throw my purple tokens down however I want. Let's do this. Let's take a really awful one. I'm going to put 3 consecutive. Then how do my numbers attach to these? Well, again, day 1 just goes on the purple token number 1. Day 2 goes on the purple token and shift over by 1. The second token, shift over by 1. Day 3 goes on the third token, shift over by 1, 2. Day 4 goes on the fourth token, shift over by 3. 1, 2, 3. And then day 5 goes on the fourth token, shift over by 4. 1, 2, 3, 4. Now, what do I need to be careful with here? My end constraint has actually changed, right? Because here I'm putting my token on D5 minus 4. I need to make sure I didn't go off my calendar here. So for that, I just have to say, well, this is less than or equal to 28 minus 4, which is 24. And now the problem has become a simple throw down the choices problem. No matter how I put down these purple dots, as long as I don't put one past the 24th day of February, however I choose the 5 days in here, I can always assign a specific place to put my work days for the med student in such a way that solves the problem. So the answer, we have just enough room to write it, is 24, choose 5. So by taking into account the fact that we don't have the consecutive days that are allowed, all that's happened is I've changed from 28, choose 5 down to 24, choose 5. So this is a common problem that we have when we have a sequence with some kind of constraint and we want to make it more spread out. All we're going to do is limit our choices.